Here we'll be looking at an application of lines and a good use for lines. So these are called trend lines and correlation. So as you can read here, scatter plots are used to illustrate the relationships between two groups of data. And so down here in our table, we have the year of a certain company maybe, and then the sales and revenue. And so 1966, maybe that was the beginning year, maybe it wasn't. There was 5 million in revenue, and then 5 years later there was 6 million. Another 5 years later there was back to 5 million. And then 12 years later, 1908, 11 million, and it keeps growing through the years. And what we can do is we can go what's called draw a trend line. So a trend line can often be drawn on a scatter plot to show the relationship more clearly. A trend line is drawn as close to as many points as possible, and it can help predict useful information. So if this company wants to try to predict what the sales will be in 2020, they may try to draw a line in here to represent what's happening with the company and then have a good prediction of what it will be so they can plan for that. So here we're going to use the graph to determine the equation of a trend line that models the sales revenue. And so first of all, we want to put a trend line in here. So what we're going to do is we want to put a line in here that best represents this. And it looks like we can put a line. We want to put it to as many points as possible, close to as many points as possible. So maybe there, where you notice there's a few points above, some points below. These are all pretty close up here. So there's a trend line that could represent this relationship. And then use the equation, and determine the equation. So we drew the trend line, and now we want to determine the equation. So what we can do is we can try to choose two useful points here. I'm noticing here's a point here at 1972 and 6 million. And then up here there's another good point to use, and that's at 2002 and 16 million. So what we want to do to find this equation, we need to find the slope between these 2 points that we have here. And so this is 1972, and this was at 6 million, and we can just use a 6. We don't have to put the 6 years after here. And then at 2002, and this was at 16 million, so we'll put a 16. And so to find the slope, we want to do the y values. We can do 16 minus 6. That's the difference in the y values. So y sub 2 minus y sub 1, and then 2002 minus 1972. That is 30. Well, let's write it out. So 2002 minus 1972. And so we have 10 over 30. If you do that subtraction, which is 1/3. So our slope is 1/3, and now we can use point slope form along with one of those points. And so let's use this one. So y minus 6 equals the slope, which is 1/3, and then x minus x sub 1, which was 1972. So if you remember the equation, point slope form, I'll write up here, it's y minus y sub 1 equals m times x minus x sub 1. And that's the equation we're using and plugging in our values. We distribute this 1/3, so we get 1/3 x, and when we multiply here, we get 1972 over 3. And we can add 6 to both sides. And over here, when we add 6, I'm going to put it up here. We can get a common denominator, so we need to multiply by 3 over 3, which this is really 18 thirds. So we got negative 1972 plus 18, which gives us a negative 1954. And so we get y equals 1/3 x minus 1954 over 3. And if we figure that out, we get y equals 1/3 x minus 651 1/3, or 651.3 continuing, you could write it. So I know I squeezed that in there, but there's the trend line. It says use the equation of the trend line to estimate the sales revenues for 1995. Sorry. And predict the year in which the company will have sales of 24 million. So we want to do two things here. We want to figure out the sales for 1995, which is in the middle here. So we could try to find 1995. So there's 1992, 94, 96. So coming up here, 1995, it looks like it's going to be around 13 million. But what we can do is we're going to use the equation. And so we're going to put y equals 1/3 times 1995, putting our x value in there, minus 651 1/3. And so if you multiply that out, so 1/3 times 1995 is 665. Subtract 651 1/3. If you subtract that, you're going to get 3 2/3. 13 2/3. I apologize. So 13 2/3. So in 1995, and remember this is measured in millions, so 13 2/3 millions, or we could think of that as 666,666.67 if we go all the way down to cents, something like that. So that's one part. Now, since they were describing things in millions, we would probably put our answer in millions. The next part says, when will they have $24 million? Well, that's our y value. So now what we're going to do is we're going to take our equation and we're going to put 24 in for the y. So 24 equals 1/3 x minus 651 1/3. And so we would add 651 1/3 to both sides. And over on the left side, if you add this, we will get 675 1/3 equals 1/3 x, multiplying both sides by 3. We'll solve for x, and so x will be equal to 675 times 1/3, which is 2026. And so what does that tell us? That tells us in the year 2026, the company will probably reach $24 million. That's their prediction. So what we could do is we could make our trend line. We draw that trend line as close to the points as we can. We were able to find the equation of the trend line, which was right here, and then we were able to use that equation. We could plug in different values to make predictions. Which prediction is likely to be more accurate and why? I would say the 13 2/3 million is more accurate because it's closer to our cluster of points. This is a prediction line, but that's measuring out, it seems like 16 more years, which is way out here. So our 13 2/3 million is going to be our closer estimate. And then we have different types of linear correlation. And so linear correlation describes how closely the data points are clustered along the trend line. So as we look along here, in this first one here, this we would say is a strong positive correlation. All of our points are clustered pretty close together, so we could make a pretty accurate trend line in there. Actually, it might be even up a little bit further, that second one. So that's strong positive. It's called positive because it has a positive slope. It's moving up from left to right. This one really has no line. We can't put a line in here anywhere that really shows a good correlation. So that's no or little correlation. Here we see this is coming down left to right. So that's a negative slope. And so we would have that, say that strong negative correlation because all the points are really pretty tightly clustered. Our next one, it's still a positive correlation, but the points are spread out more. So it's a positive slope, but it's spread out more, so that's why it's a weak correlation. It's not as tightly clustered. And then here's a weak negative correlation. That's probably a better estimate somewhere in there. It's negative because it's coming down left to right, has a negative slope, and it's weak because not a tight cluster here. So that's trend lines and then correlation. Trend lines are very helpful for predicting different things and are used in businesses and other applications.